Hi children, today we are going to discuss about factors on which resistance of a conductor depends. Before we are going to discuss about these factors, some other terms you want to remember. Among that one is how the current and resistance are related. Here you see current is inversely proportional to resistance. This means as the resistance increases, current through the conductor decreases. So current is inversely proportional to the resistance. If the resistance is doubled or resistance if the resistance becomes 2 times, then the current becomes half. Current becomes half. Then another terms you want to remember what is actually a conductor, a resistor, poor conductor and insulator. First of all, we know electric current is the flow of electrons. When electrons flows through a conductor, it offers certain hindrance to its flow. When electrons flows through a conductor, the conductor offers some hindrance to its flow due to the attraction of atoms inside it. So, when we consider a material of given size, if it offers very low resistance, that means if it offers a very low resistance, then that material we say as a conductor. And if it offers up to a certain resistance, then it is called a resistor. If it is offers a low resistance, then it is conductor. If the same size the material offers some resistance, then it is called a resistor. If the same size material offers more resistance, then it is called a poor conductor. If it offers more resistance, then it is called a poor conductor. If it offers a higher more resistance, then it is called an insulator. So we can classify materials based on its conductivity as a conductor, resistor, poor conductor and insulator. Now we want to discuss about how or on which factors or on what factors the resistance of a conductor changes, and from that we want to define a term resistivity also. For that we can discuss about an activity. For that see, a circuit is made as shown in this figure. See here a battery, ammeter, plug key, and material required to do this activity are nichrome wire of length L. Say it is about 50 centimeter length. Then another nichrome wire of length 2L, 2 times length. Then another nichrome wire of same length but its thickness more. Then a copper wire of same length. Now first see, we connected nichrome wire of length L in between the points X and Y. And when we connected this nichrome wire in between this X and Y, current flows through this circuit and ammeter shows current through the circuit. We note that current in the ammeter. Then replace this nichrome wire of length L, and instead of that we use another nichrome wire of same thickness but length 2 times. That means length now it is 2L. And again we measure the current in the ammeter or observe the current in the ammeter. Now the current you can observe it becomes half. When the length is doubled, you can observe current in the ammeter becomes half. Now see, then this nichrome wire of length 12 replaced with a thick nichrome wire of same length L. Now again observe current in the ammeter. Now current in the ammeter you can see increased. Current through the ammeter now it is more. Now that thick nichrome wire replaced with a copper wire. So again you can note that a current increased. So from this activity we came to the conclusion that resistance depends on length of the conductor. This means as the length of the conductor increases, resistance of it also increases. Then second one, its area of cross section. Area of cross section. Otherwise it is called the thickness of the conductor. Second factor is area cross section or cross sectional area of the conductor. And third one is the nature of the material. That means nature of the material means instead of nichrome, when we use copper wire, current through the circuit changes. So resistance depends on the nature of the material also. Then another one more factor you should remember is the temperature. Temperature when changes, the resistance of the conductor changes. So the four factors on length of the conductor, second one area cross section, third one nature of the material, and fourth one temperature of this conductor. That means resistance depends on these four factors. Now we want to find out how this resistance changes with these factors. First of all, see resistance of the conductor directly proportional to its length. This means as the length increases, resistance increases, or if the length decreases, resistance also decreases. That is R proportional to L. And R proportional to, that is resistance is inversely proportional to area cross section. This means as the area cross section increases, resistance decreases. Now we can combine these two, that is R proportional to L by A. R proportional to L by A, we can replace this proportionality with equal to sign. For that we want to give a constant, and that constant is rho L by A. This rho is called resistivity of the material. What is called rho? Rho is the proportionality constant, and here it is called resistivity of the material. That is resistivity of the given material. From this relation, rho is equal to, how we will get from this relation, rho is equal to R A by L. Now we can find the unit of rho. Rho is equal to unit of resistance ohm, unit of area cross section meter square, and unit of length is meter. Now from up and down we can cancel 1 meter. Then what is the unit of resistance? It is ohm meter. The unit of resistivity. The unit of resistivity is the which is the unit of resistivity? Ohm meter. SI unit of resistivity is ohm meter. What is actually resistance and resistivity, or how they are related? That means resistance is the material of any length. That means when if its length is 25 centimeter or 50 centimeter, whatever is the resistance, that means hindrance offering to the flow of current, that is the resistance. But resistivity is also resistance, but it is for a conductor of unit length and unit area cross section. A conductor of unit length and unit area cross section, whatever is the hindrance in it, that is called resistivity. Resistivity is the resistance of a conductor of unit length and unit area cross section. So rho is equal to, its unit is how much? What is ohm meter. This resistance and resistivity varies with the temperature. But for a material, resistivity is the same. For example, for copper wire, its resistivity will remain same if the temperature is not changes. Does not change. If the temperature not changes, then its resistivity is not changed. If the temperature not changes. And for aluminum, then its resistivity is another one. That means when the material changes, its resistivity also changes. Materials like conductors such as metals like copper, aluminum, etc. Its resistivity is very low. It is of the order, that means resistivity of what is metals. It is of the order 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. So these materials we use as conductors. But materials like glass, rubber, etc. its resistivity varies from 10 raised to 12 ohm meter to 10 raised to, that means 17 ohm meter. That means so they are act as insulator. So these are act as insulators. So metals we know are good conductors because its resistivity is low. But we know what is glass, rubber, etc. insulators because its resistivity is very high. When we consider the case of alloy, alloys used to make heating elements. We used alloys for making heating elements. Why? Because its resistivity is more than the constituent metals. Suppose when we take nichrome, it is an alloy of nickel, chromium and iron. It is an alloy, but its resistivity is higher than nickel or chromium or iron. So and one more property of it is that its melting point also high, so it does not get oxidized readily at a high temperature. It does not get oxidized at a high temperature. So from this you got idea about the factors affecting resistance of a conductor and also resistivity. And if you got idea about these factors, then like this video, share and subscribe. Thank you.